Hi guys, in our last lecture we studied electrocyclic reaction. In electrocyclic reaction we saw the definition, properties and selection rules. We'll quickly revise these things and then we'll move further. What is the definition of electrocyclic reaction means? These are intramolecular reactions in which one new sigma bond will be formed between ends of conjugated phi system. This is definition. And then we studied the properties of this electrocyclic reaction. First property is these are intramolecular reaction. Second thing is these are one-step reactions. Third property we saw is this in this reaction one new sigma bond will be formed. One new sigma bond will be formed. Fourth property we studied is in this reaction product containing one less pi bond. So these are the properties of electrocyclic reaction. And then we studied selection rule. In selection rule I explained if the condition is 4 and pi and thermal condition means it is a conrotatory. 4 and pi system and photochemical condition means disrotatory. Next we studied 4n plus 2 phi system and thermal condition means it is a disrotatory. 4n plus 2 phi system plus photochemical condition means conrotatory. These things are very selection rule is very important to solve the examples of electrocyclic reaction. Now with this knowledge we'll solve some electrocyclic reactions. In electrocyclic reaction two kind of examples you'll see. First thing is ring closing type and another one is ring opening type. First we'll see the first type, that is ring closing. Consider first example. Look at here, there are 2 pi bonds. 2 pi bond means you know that it is 4 pi electron system and the condition here is thermal. 4 pi electron system and thermal, you know the selection rule, you have to do the conrotatory. This pi bond will be shifted here to form a new pi bond and this pi bond will be utilized for the formation of new sigma bond. The basic product is this one. Then the stereochemistry will be decided by this conrotatory. Conrotatory means you already know that moving in one direction. Here what is the imagination is, standard assumption is these are on a plane of paper. This when we flip in this direction H comes above and CS3 goes below. H and CS3 goes below. Here if we move in this direction, these two groups H come above and CS3 come above and this H comes below. The stereochemistry here is trans. We'll solve this example. Here also it is a 2 pi bonds and 4 pi electron system and the condition here is photochemical. You know that photochemical condition and 4 pi electron system means you have to do disrotatory. Disrotatory means you know that either moving inside or moving outside. What we'll do here is we'll move inside. First we'll write the basic product. This pi bond will be shifted here to form a new pi bond and this bond will be shifted here to form the new sigma bond. The basic product is this. Here it is pi bond. The stereochemistry, you know, it is by disrotation. These two groups will be shifted in this direction. If we shift in this direction means H comes above and CS3 goes below. H, CS3 below. Here if we move in this direction H come above and CS3 goes below. The product is CSIR. We'll see the second type of an example. Here again it is a 4 pi system and And a thermal condition, you know that 4 pi system thermal condition means you have to do the Kahn rotation. First we'll write the basic product. This pi bond will be shifted here. This will be utilized for the new formation of new sigma bond. Basic product will be like this. Kahn rotation means in my last example I rotated this direction, right? Now we'll change. We'll change that to this direction. See, moving in one direction. Kahn rotatory means moving in one direction. So if I move these two groups in this direction means H comes above, and CS3 goes below. This wedge indicates that the group is above. This dot indicates that CS3 is below. Here if we move like this, these two groups, H comes above and CS3 goes below. The product is CSIR. In the next example, again it is a 4-5 system and the condition is photochemical. You know that 4-pi system photochemical condition means you have to do the disrotatory. Disrotatory means moving either inside or outside. In the last example, disrotatory I showed you by moving inside. Now I will show moving outside. You can do any one, either moving inside or moving outside. Both are same only. Both gives the same result. First we'll write the basic product. This pi bond will be shifted here for the formation of new pi bond and this for the new sigma bond here. So if we move in this direction, H come above and CS3 comes below. Here if we move in this direction, CS3 come above and H comes below. So the stereochemistry here is trans. Third example we'll see here. Again here there are 2 pi bonds. 2 pi bond means you know that 4-5 electron system plus thermal condition is there. If this means you have to do what? Kahn rotatory. One special thing about this example is this is a rigid system. The entire system is rigid system. Only hydrogen will be moving above and below. Kahn rotation. First we'll not think about it. First we'll write the basic product. This pi bond will be shifted here to form the new pi bond, and this pi bond will be shifted for the formation of new sigma bond. We'll write that basic product first. Here Kahn rotation you have to do. Kahn rotation means moving in one direction. See, what we are doing here is this direction means H will go below. Look at here, flip, H will go below. Here you are moving in this direction means H comes above. This is trans. Again the same system we are using here, but the condition I am changing. 4-5 electron system plus photochemical condition. You know that this combination means you have to do the disrotatory. So first I will write the basic product. This will be the product here. Only the change is stereochemistry. Look at here, disrotatory means you have to move either inside or outside. So we'll move inside here. If you're flipping in this direction, hydrogen will go below. So I will write this. If you're flipping in this direction, again hydrogen will go below. So you will get this. So the product is cis. Next we'll see is fourth type of example. Look at here, it is a 6 pi electron system and the condition is thermal. 6 pi electron system and the condition is thermal means you know that it is a disrotatory. First we'll write the basic product. We'll shift this pi bond to form a new pi bond, and this to form a new sigma bond. So this is our product here, and the stereochemistry will be decided by the disk rotatory. Disk rotatory means either moving inside or outside. We'll move inside. The CS3 and H, if we move in this direction, means CS3 comes above and hydrogen will come below. Here, these two groups, if I move in this direction, means H will come above and CS3 will come below. So the product is trans. Again the same system, 6 pi electron system, but condition is changed, that is photochemical condition. You know that 6 pi electron system and photochemical condition means it's a conrotatory. We'll write the basic product, we'll write first. We'll get this product. Only the thing we need to check here is stereochemistry. Conrotatory means you know that you have to move in one direction. You have to move the groups in one direction. So if we move these two groups in this direction, means CS3 comes above. CS3 comes above and hydrogen comes below. Here, if we move in this direction, means CS3 comes above and hydrogen comes below. The product here is cis. Next thing we'll see is we are changing the position of methyl groups here. So again, the 6 pi electron system and thermal condition, you know that you need to do this rotatory. Here it is 6 pi electron system and photochemical condition means you have to do what? Conrotatory. We'll apply this knowledge here. Basic thing is you need to write this product. You have to decide stereochemistry, that's it. This rotatory means either moving inside or moving outside. We'll move inside. If we move inside here, this hydrogen and CS3, inside you are moving in this direction, means H come above and CS3 comes below. H come above and CS3 comes below. Here if you are moving in this direction, you have to flip. So H comes above and CS3 goes below. So the product here is cis. Here you need to do conrotatory because 6 pi electron system and photochemical condition. Conrotatory you have to do. Basic product I will write first. Then stereochemistry is by con. Con means you know that moving in one direction. So if you are moving in this direction, this H comes above and CS3 goes below. So H comes above and CS3 goes below. And here if you are moving in this direction, this group comes above and H goes below. This is trans product. So these are about the ring opening reactions. Sorry, these are ring closing reactions. In my next video, we will see the ring opening reactions.